So, Boats, I think you said you had an outline in your head of how to present. I feel like we should start, maybe, I don't know about the rest of you, but I found when I was reading over the thread that I was kind of confused on a lot of fairly basic things, and it would be helpful to just kind of lay out the problem.
Yeah, I think I can give a summary of the situation again.
I'm going to share this paper doc if I can figure out how.
Where is the background already? Is this our discussion from a month ago?
No, this was me trying to write stuff. I think I can. I'm happy
Cool.
if we just want to ignore it.
Yeah, I was just curious. 1 sec. How do I freaking escape? It went full screen and now I don't know what to do.
I think Zoom has some default setting.
You might want to put the meeting notes below so that things don't jump all the time.
I can double click to remove to leave full screen.
I'll double click there. I was trying to escape and it was not working. Thank you.
Yeah, I mean, there's literally a key to leave menus. Why would that work to leave a menu? That nobody would expect that, right?
Yeah, definitely.
Yeah, I'll just put these up here, but I don't know if they're. I'll probably erase them at the end.
Cool. So someone else will write, and
I'll try to take notes.
Yeah. So. So there are two unsoundnesses. Well, there were three, but one we agreed was just a bug, and we fixed it. So we'll be looking at the two that still remain today. And so as background, PIN is a contract between three different parties, basically. The three parties are the person who defines the target type that the pinned pointer points to. Then there's the person who calls a method that takes a pinned reference to that type. And then there's a person who defines the actual pointer type that is pinned. And most of our documentation and focus has been on the first two of these because that's what most people want to be doing. Either they're creating a self.
You said, what was the three?
The third was the first is the person who defines the target type. Not the first person who defines T.
Not P, but P, but like the ampersand, the T and pin ampersand UT.
Yeah, P target. Yeah. And then the third one is P, which for the most part has been the standard library, though there are a few, like pin utils also create sort of counts and pin cell. But basically no one is really, I guess the standard library is technically, standard library is defining pin, which creates the contract, right?
Right.
Yes, but also basically all actual pointer type that get used, like pin utils calls pin new and stuff, but do they call it on any types other than references and box and arc and RC?
Exactly, yeah. So basically we focused most of our attention on the first two of these and not the third one, and it turned out there were ways to be unsound without unsafe code. If you were defining the pointer type, is sort of the high level view of what happened.
Just from a stability point of view, I don't think this is a big problem in practice, but it is technically possible to define in stable code, right? Like new P's that work with.
Yeah, that's right. Because of fundamental, that's the fundamental route is stable.
No, that's just the fundamental is for doing this with ampersand.
Oh, I see what you mean. Yes, it's possible to find new P's, but there's only one route to do without any unsafe code. That's sort of the unsafe.
Right, but even with unsafe code, there should be a way to do it reasonably.
Yeah, and there totally is so as long as you can define your own pointer type and then prove that you've made it correctly and then create a constructor on safe code today.
But we would be in patching this, we'll be kind of updating the contract somewhere along the line. So it's technically a breaking change.
Possibly it could be a break. Yeah. Well, I think no matter how we solve this, because we'll be breaking the code that is unsound. And then it could have different solutions have different impacts on different users, possibly. Yeah.
I would also say we're less updating that contract for the third part if you're more defining it for the first time, because so far we haven't really.
That's true. That's true. No matter what we do,
that's kind of the problem.
I was being generous, but yeah.
I mean, I'm not sure how much everybody is aware of the history because there were previous versions of the pinning API that didn't have this 3-party thing. It was more a 2-party thing to some
I
extent.
think you
The third
shouldn't
party
go
was
too
fixed.
much into it because I mean we have
I think that's
limited
useful for
time.
some of the discussions, at least for the way, at least in my head, that helps a lot.
Yeah,
But,
I mean, I think it's a sort of, in a retrospective way, it explains what happened, right? Because we proved correct, like pin of a mutable reference and pin of a box. And then we realized we could abstract it as long as we made the constructor unsafe. Oops, there were ways to do it without like to get around that, right? So like when we abstracted it, we didn't then prove that we had like really shored up the problem, I guess, and that's how this happened.
All right.
Yeah. So should we go over how exactly the unsoundness works, or do we have everyone have a good
That would be helpful.
Yeah.
What I was saying to Ralph is I would sort of find it helpful to show, maybe I'm unique here, but I know it involves like pin as mute and there's a kind of hole through the coherence rules, but if maybe it's helpful if we simplify it even more and say like, just pretend the coherence rules weren't there and you can see why this is clearly wrong, but we thought that couldn't happen, but we were wrong.
Yeah. Well, because that's the fundamental route, but there's also the coarse and size route. So
yeah, that's true.
Yeah, what they all share is that you construct a valid pin pointer to, let's say, address A, but somehow in your code, your pointer type swaps out and creates a pointer that dereferences to address B, which is not actually pinned, which you haven't proven is pinned. And so you meet the pin requirements somehow, and then you actually get a pinned pointer to a different address, which is not necessarily pinned, and then you drop your pin pointer or whatever, and then you move it again. And so
specifically it's going to be an and mute.
Yeah, yes, I guess they all give you a pin mutable reference to. Yeah, that's correct. Well, because ultimately a pin mutable reference is the only thing that we're really protecting. Because
I mean, there was also an exploit, but that's fixed. No, that's not fixed yet with pin ampersand T and clone. So it's not just ampersand.
No, that's just pin ampersand mute and clone, because pin ampersand does implement clone already. Generically, that's also ampersand mute, because ampersand mute doesn't implement clone.
Oh no, that was the partial EQ one that needed the ampersand.
Yeah, that was the one that was the one that was just a bug that we fixed.
Well,
all right,
it's similar category as far as I'm concerned. It's the same bug, but okay. That one was easier to fix.
Well, I think what we did was we decided we made partial EQ no longer like a part of the proving correctness. You no longer have to prove that your partial EQ is correct because we don't call it.
Yes, because that's kind of the background here is that the way this somehow happens in your code is through a quote unquote evil deref or deref mute implementation or clone.
Yeah. I think that's true even for the coarse unsized route. Yeah. Yes.
Yes. And previously it was also possible to have an evil partial EQ or hash and I don't know which other trait things, but we short-circuited those basically. Yeah. So the user no longer has any control over which partial EQ gets called. It's just going to be the default one and then the one for the target type, but the pointer type has no say in it.
Yeah. Let's see. So I think probably.
Do we know that the evil deref mute or clone we know those are the only two routes, or those the only two known routes?
Those are the only two known. The deref mute and clone. I feel pretty sure, but we haven't formally proven it or something like that.
But there's 3 traits involved: deref, mute, and clone. So all the bad stuff is going to be through one of these traits because we short-circuited the others.
Speaking of how much work would it be for to prove this formally in Kotlin?
We'd have to formalize the trait system.
Well, not entirely sure, but I can report on our side of that later, I guess.
But can we show? I still don't fully grok the unsoundness again. It's still out of my head. Maybe just show an example or something.
I had a really small reproduction somewhere.
I think it's this one.
Yeah. So here your mute like points. So what does this do?
Right. So the evil deref mute takes.
This doesn't even use dyn.
It takes it has to produce somehow an ampersand mute, which is hard to do, but it does it by, it's hard
Using
to
a
do
cell.
because you have an ampersand coming in, but it does it by a cell, right?
Mhm.
Cell has replace which returns a reference.
So yeah, and I think that the only way to actually get like observed miscalculations of this is using manual. Like it doesn't work with like features and await or anything, but it does actually show the like fundamental incorrectness, which is that. So you pin a box pointing to my type, which contains another pointer to a my type inside of it. And then your deref mute actually points to the unpinned. So there's two values here, the pinned one and the unpinned one. When you call pinned ref as mute, what you get is a pinned pointer to the unpinned value, which was not actually contained inside the pin, because pinned ref as mute calls deref mute on your reference to my type, and then that does the evil swap.
Yeah, so pinned mute ends up pointing to unpinned.
Yeah.
But temporarily, because but when the lifetime is over, we can actually get unpinned access to unpinned again, and that's
yeah. As soon as we drop the pinned box thing, the pinned value unpinned exists again, and you can move it if you want.
Right. So you can. Like this.
Yeah. Yeah.
So it's star unpinned kind of would be the wait. Is it it's in the box, right? So that would be the actual move.
Yeah, that was probably.
Okay.
Yeah, I think this actually, like, there might be like it might tie the lifetimes in a weird way, so you might actually have to use manually drop to really do this. But like,
because of the lifetimes. But yeah.
Yeah, but like fundamentally, you should not be getting a pinned pointer because you haven't proved that it's pinned. So like this, even if you like can't exploit this example shows the.
Yeah, there are exploitable examples.
And here the sort of construction of the pin that
right. Yeah.
that didn't work is in as ref itself, right?
No, it's in as mute. So first we do as ref to get just a pinned normal reference, and then with a pinned shared reference, you call pin as mute to get a pinned mutable reference, and this is because you've implemented deref mute for a shared reference.
Right. I think this is actually sort of the heart of the Ralph Boats dispute, though, right? Like somehow one of these two things shouldn't be allowed to occur together, kind of.
Yeah. Well, I think we agree on that. It's that we disagree on how to resolve the issue.
Yeah, kind of.
Which one is to blame, that is?
No, we both disagree that this impl should not be allowed to exist, I think. But
the impl is the bad one.
Or rather, we both agree that actually, no, I think Ralph would just think that impl should not be sufficient to call as mute. I think because Ralph would add a marker trait, so you'd have to add unsafe pin deref mute to my type, and that would solve it. Whereas I want to just make it so that would be an incoherent impl.
Yes.
How is that achieved?
What?
You can't write it. If you can't write the impl, then it's also like either writing the impl is okay, but not sufficient for pinning, because pinning requires an extra checkbox to be ticked where the user says unsafe impl pin deref mute blah 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 something to like basically certify I verify that my deref isn't evil. Or we make it that the impl can't be written in the first place, so that there can't be an evil impl.
How is somehow achieved?
I think that Nico had the right approach. This would be possibly we'd want to do this with language magic today, but in the long term, what we're looking at is these negative impls, where a negative impl is an assertion that this impl will never exist, and then later on be used in coherence proof that a type does not implement a trait, for example.
So it's like a positive witness for a negative fact.
Yeah.
Yes.
And we've done a lot of this was sort of an old idea that we Chalk was kind of exploring originally, but we haven't done a lot on in the last few years.
It feels more risky.
So
it's also worth pointing out that these are not actually contradictory.
Right.
Yeah.
I think there's value. I think Boats's point that it's very surprising that ampersand T permits this deref mute impl, and it's the kind of thing that we might like to make impossible is true. But it may also
there's kind of no good reason to allow such an impl, basically, was the argument, right?
Yeah.
But the unsafe trait seems like to me like something that the pin DRF mute approach is sort of like, we know that's going to fix this problem. It might cause more, unhappiness in the ecosystem, but right, it seems easier to make that argument that it works.
So right, and I think that when Nico and I talked about this last month, we sort of got to it, because right now the way it works is if you define a pointer type that can be pinned, you make it unsafe. It's unsafe to construct it, and so you have to somehow, you have to prove that your pointer type meets the requirements.
But say that we add the market trait, the unsafe market trait. It should be forward compatible with removing that requirement in the future if we find out that it wasn't a good idea, right?
Well, I mean, the unsafe market trait will be stable, so it will always exist.
Yeah, but you can implement it for all types, so you can effectively remove the requirement by implementing it for all types.
I mean, that's not. I don't think that completely it still exists, and then you have to. Then actually, I would rather just have it exist than have to explain how it exists but doesn't do anything anymore. Personally, but
yeah,
wait, why would it exist but not do anything? Also, that seems incoherent.
Like if we were to then,
traits.
if we were to then add negative impulse later and then just make it.
Okay.
Market traits have no recognition.
That's not stable yet, is it? I guess in the full libacity that's not a problem.
That's true, but I mean we can make it stable in the future.
So I mean it has to. So this has to be something that we make stable, or we or we have to add pin deref mute stably, or we remove the ability to define your own pointer types. Even adding it stably is a breaking change to anyone who has defined their own pinned pointer type.
Yes.
Including, for example, the pincell library.
Pincell defines its own pointer type?
It might not, actually.
I have not heard of a single custom pointer type yet, but I also don't have a good overview over the ecosystem.
What's the name of the
You might just give out a pin of ref mute. So, I need to look at pincell again, and actually, I'll get back to you on that. That's actually a fair point.
But there's also a big unless here, which is a big wrench into this plan, at least formally speaking, which is that you can actually safely construct a pin P with any pointer type P if P target is unpinned.
Yes.
So we are never.
No.
Sorry, you were starting to say something?
Like, isn't that that's just ultimately the coercion size problem? No.
Is it? I don't see that connection.
Well, I mean, you can construct a pin. Like none of the pin requirements matter if the target type is unpinned. The problem is that coercion size allows you to take a pinned pointer to a type that implements unpin, and then coerce it into a pointer to a type that does not implement unpin.
Okay, but you do that with a reference, right? You don't need a custom pointer type.
Yes.
So that's not what I meant. What I meant is if we want to get a control over which pointer types are used, if you want to make the pointer type opt in and promise that their impulse, deref and deref mute and clone aren't evil, that doesn't work with the current pin new. We would require.
Don't matter. No, but we don't need to control it unless the target type does not implement unpin. That's the.
Well, I mean, that makes sense, but I can't formally. So we had a long discussion. Well, it was a single lunch, but it was a long lunch discussion with some people here about trying to put that into a formal invariant, because the key question when coming back to centrals is how much of this can be formally proven or whatever, is we need to figure out what is the invariant for pin P for any arbitrary type P.
Yeah.
We have a formal, so the current status of formal proofs is that we have a formal model of pinning, but it's kind of the old style where there's separate types for pin, shared ref, pin mutable ref, and pin box. So those three have invariants, custom invariants. And then for those, we have defined and proven the basic operations and some kind of self-referential, like something, if you take the async part and strip it down to the core that requires pinning, where you have a self-referential pointer setup, we have an example like that proven correct with this API. But there's nothing like pin, like the generic pin P for any P, because we have no good idea of what the invariant would be.
Right.
And so we tried to come up with an invariant, but the entire point of the unsafe trade thing and so on, at least the way I think about it, would be to basically make it so that the invariant, currently the problem is pin P you can say for any type P. P doesn't even have a pointer type to state pin P. The trade bound is only on the constructor, not on the type.
Mm-hmm.
So we have to define the invariant for any type. And so we can't talk about the target type even. It's completely unclear. Now maybe that's not such a big deal, though formally I'm not entirely sure about it. But generally the idea would be that the invariant would refer to the pin variant of the pointer, right? So the invariant for pin ampersand mut t should be exactly the pinned mutable reference invariant that we have for the old style of the API, and so on. But that can only work if this invariant is defined by the respective pointer type, which means constructing the pin of the pointer type must have a way to learn about that invariant, and it can't with pin new, which has no bound.
Okay, so can I try to restate that, because I totally was not able to take any minutes, but
I'm not sure how much sense that made. I'm sorry.
I think what you said was, basically, if you have these traits, every impl gets to define its own invariant, essentially, or its own invariant for the type. Each type gets to define its own invariant, which you do sort of by declaring this unsafe impl, as opposed to needing one invariant for pin of all P. Is that right? That makes sense to me.
But. So maybe it's easier to say what the invariant could be if we redesigned this from scratch. I'm not saying this is the best way to design it, but if we could make breaking changes. Because then one way we could imagine the invariant to be is if pin had a bound on the type.
Yep.
And then, okay, this in here would be just a P. I guess it's actually a tuple struct or whatever. But the actual invariant, so the deref pin trait would be unsafe.
Yeah.
And it would inherit from deref. And the unsafe trait contract would be a really complicated one, which would basically say that this pointer, I tend to have colons before, spaces before my colon sometimes. This pointer, this would basically pick the invariant. So the actual invariant picking would be done when you say unsafe impl deref pin for a particular type. You would say, what is the pinned version of this pointer?
Okay, that's what I was trying.
But I think, why is that not the same as that you would then define the invariant either when you have a call to pin new unchecked, or when you implement coerce unsized, assuming coerce unsized is made unsafe?
So I haven't thought much about coerce unsized. I don't know even very much how it works.
Yeah.
So I've ignored that.
Is this sort of what you're saying, Ralph? Language? Kind
of. I mean, it has to somehow, and I forgot the details, refer to the deref target type, because that's relevant. I think. Maybe, probably.
What I'm trying to figure out is there must be something you can say about all these types, right? But it's just very.
But I think that, do you meet that? I don't think there's any difference even improving it, because in order to get setting out outside coerce unsized, you have new unchecked, which is bound a deref, and so you prove the invariant in the on the impl where you call new unchecked. It's the same as that location, that unsafe block where you're calling a new unchecked is where you are making the proof, and just in this case would be on the deref pin.
The question for me isn't even yet where do you prove it, but where do you even define what the invariant is?
On new unchecked.
Right, but that's not, I mean, that can't really work, right? Because there could be many places that do new unchecked for the same type. And
Can,
how do
can
we
I
make sure they all pick the same
can I
invariant?
double check the invariant here you're referring to? It's something like the pointer you get back from deref is always the same, right? Or is there some other invariant here that I'm not?
The invariant is,
And there's no other unpinned pointers to it. I think that's basically.
I mean, formally speak, well, the invariant is ultimately up to the target type.
Yeah, because like
the target type in its own way exploits the fact that it's pinned. So for example, a self-referential generator will have an invariant saying something like, oh, when I'm pinned and there is this pointer and I'm in the state where I can have a pointer to one of my other fields, then the pointer actually points to my own location, because a pinned invariant of a type can talk
I see.
about the
When you
location the
add those
data
things
is in,
predicates.
which is the key difference to the unpinned invariant of a type, right? Vec has an invariant and it says, oh, my pointer is non-null and it has size capacity and the first length elements are initialized. That invariant can't talk, it's not allowed to talk about the location where the vector is in memory, because that can change because it's a movable type. Please fill in, Rev. But the pinned invariant of a type, which is a basically completely independent beast, though the two are connected, is allowed to talk about what does it mean to have a pinned instance of a type at a particular memory location. And so then self-referential generators will say, oh, that means I can have pointers into that same space, or intrusive linked lists will be able to say, oh, the other list elements can point to those locations, stuff like that. And so the general principle that follows all of that is that the location can't be moved and stuff like that. But that's not literally in the invariant. That's a consequence out of having to preserve the invariant and not knowing what it says about the location.
Right, but so the pointer type is then like proving that it gives the target type that invariant.
Right, the pointer type has to prove that when you call deref mute on a pinned thing, then that's okay, first of all. So on a pinned mutable reference to the type, because that's not obvious that that's okay, right? The deref mute type signature says you can call it any mutable reference, but now we are calling it on a pinned mutable reference, which is not the same thing. Mm-hmm. So the contract will somehow have to say, oh, when you call deref mute on a pinned mutable reference, first, that's an okay thing to do, and second, then the return thing is also a pinned mutable reference.
Yes.
Oh, sorry, the argument is not a pinned mutable reference. The argument is just the pointer type. Yes.
No.
So when you call it on a pinned version of this pointer, like a pinned box or a pinned arc or something, that's an okay thing to do, and the return value is a pinned mutable reference. That would be the kind of contract. That would have to be proven when you say unsafe impl deref pin. Except when you say unsafe impl deref pin, you can't talk about deref mute because it doesn't inherit from that. So you would need another deref pin mute and another deref clone, and it kind of gets annoying.
Yeah. By the way, we're at 30 minutes.
Yeah. What I thought would be, somehow I feel more confused than when I went in, but what I thought might be helpful for, like, it seemed like we were kind of having a bit of a not stylistic, but a debate about where to put the same sort of proof obligations and how to make sure they're maintained. Is it possible to kind of sketch what it might look like under the two different, like we see what the language changes would be, but what might the documentation look like of new unchecked versus these proposed deref mute trait?
Well, I think that we got to this in our 101 about this, that with the traits, then you put on each trait like the invariant, like if this implements pin deref mute, then, etc. It must therefore uphold this invariant. But without them, what you have is either this implements deref mute and upholds the invariant, or it does not implement deref mute. And I think that the issue is that proving that something does not implement deref mute formally relies on understanding, formalizing our coherence rules.
But it's also that there is kind of so in the thing that I've been very poorly sketching here, there is this intermediate step when you say unsafe impl deref pin, you define what is a pin variant of my pointer type. You kind of prepare your pointer type for being allowed to pinning, because in our formal version of this, we have a mutable reference and we have a pinned mutable reference. Those are just two different types, like they were in both original API. Mm-hmm. And so, but the pinned mutable reference pointer type doesn't actually exist as a type in Rust, But in this sketched proposal here, when you say unsafe impl deref pin for ampersand muti, you would then pick that type's invariant, basically saying it's a mutable reference to something that's in a pinned state, the pinned type state. You would pick that invariant and say, oh, this is what being a pinned mutable reference means. And you would have to do that for every pointer type that you want to allow pinning.
Would you not do that on the constructor?
No, the constructor doesn't even know that when you define the, wait, which constructor?
The constructor of a pinned version of your type, which calls new unchecked.
Well, but pin new can't do anything like that, right? Pin new works for any type P.
But that doesn't matter. But like pin new, if pin new is, that's because pin new is safe, and so pin new has no invariance because.
Well, no, but pin new has to prove that its return type is a pin of P, which requires proving that the return value satisfies the invariant, whatever invariant we come up with for a pin of P.
You can't impose any invariance on a pin of P unless the target type is if the target type implements on pin. That's a.
But pin of mu does it even require? So I mean.
Yeah, pin new requires the target type implements on pin, and so.
Yes.
So pin new requires that if you deref to an unpinned type, then you like can't impose any additional invariance on the pinned version of your type.
Right, and we have to prove that that's correct. That's trivial because we come up with an invariant for pin, and then we have to prove that pin new actually construct, just like when we call vec new, we have to prove that it's a valid vector. We have to prove that it's a valid pin thing. And ideally, this should be easy because the target type is unpin, but we have to set things up in a way that this can work. And in particular, we like this will be a constraint when we set up this invariant because we don't know anything about the target type. If we require the target type to be deref pin, in my proposal, that's basically what we have to do, that we could only call pin new on, at least when we do it completely formally. I haven't actually found a counterexample if we don't do this, but the proof would require this. That then basically when you do unsafe impl deref pin, you would prove that indeed if your thing is unpin.
Yeah.
No, sorry. This is a weird implication to state. If my target type is unpin, then because then now you're again kind of relying on coherence. Now it's just coherence of whether your type implements the unpin trait or not.
I think that.
So
yes.
you wouldn't
fundamentally
do that. You wouldn't want to do that such a case of thing. You wouldn't want to use the property of being unpinned, which is that the pinned and the unpinned type state are the same type state. Would you want to somehow use that property to make it work?
Yeah.
I'm sorry, I'm totally lost. I'm trying to understand, but because we started off and I sounded like so much just focused on new unchecked, and I thought pin new was fine because of the unpin bound. But now Ralph sounds like he's saying that that's not sufficient. Can someone please summarize that?
That formalizing that is very difficult.
Right. Basically, what I'm saying is the proposal that I originally made in that thread. I think we have an idea for how to pull it through, and it wouldn't rely on coherence. And there would be basically explicit places where the user would have to pick certain invariants, though I'm not entirely sure how to actually communicate that because it's very formal. Also, it would have a problem with pin new.
Because pin new also relies on coherence because of the way it relies on unpin.
Exactly. And so then after that, we thought a bit about what would the invariant look like for your proposal votes. And we also had some ideas there. So maybe it makes more sense to move to that because I haven't yet had time to write this up, but I'm not actually as opposed to your proposal anymore as I used to be, basically.
So I just want to make the argument for a proposal stepping out of formalism, which is, I think in practice, most unsafe APIs that people use will not be formally proven. And right now, like we have a coherence model where you can reason about, you can informally people reason that a type does not implement a trait. And as a rule, this holds very well because our coherence model doesn't allow orphan impls. The one exception, of course, is that we have this fundamental loophole, and so that's why our shared and mutable references have these ability to have orphan impls that we didn't think about when we would design this API. But basically, I think that people are going to write unsafe APIs whose soundness depends on the coherence rules working. And I think that we should like just endorse and accept that as like a way of designing APIs, even if it's difficult to formalize. And so I think that like the fundamental idea of the pin API is like the way that I think that people should design unsafe APIs in Rust, basically. That like you should be able to reason about. I know that that this impl doesn't exist, and so I know this type doesn't have this behavior, and so I know that this is sound. Like, that's how people are practically going to write.
Right, and so we basically, I mean, I don't have to elaborate on that much here, but we try to sketch what an invariant could look like for pin that is based on that principle. Mm-hmm. And I mean, I think both you will not be very surprised because it's probably what you had in your head all along, but it took me a bit to get any idea of what a formal version of this could be. But it would be basically something like so some value v is a valid pin of p. There have to be kind of three things, one for each of the three traits, which is that, first of all, if p implements deref, then calling deref on that value, on that specific value v, must be okay and must return a pin &t. So now this pin &t, so yeah, syntactically that's ill-formed because we're defining pin of p, so we can't use pin of p. But we have already defined what is a shared pinned reference.
Right.
That we can do that without defining pin. That's some definition that we already have.
Type that doesn't actually exist in Rust, but like.
Right, so this would be more like pin sure of t. And then calling, and then furthermore, if p implements deref mute, then calling deref mute on that value must be okay and must return a pin mute of t. And furthermore, if p implements clone, then, well, the corresponding thing. It must be okay to call clone on that value, and the return thing is a whatever
pin.
it is, whatever the type is that we give it, pin of p.
Right. And then you would be like creating your own, if you're defining a pointer type and you want to formalize it, you would have an analogous type to pin share and pin mute, right? You would have like pin my type. Like
No. These are the three traits. So when you so a couple observations. First of all, pin new is now justified because we cannot prove pin new because for t, when target is unpinned, pin sure of t and &t are the same type. So
right.
It's obviously correct to call deref on the &t that we just got, and it will return an ampersand. Sorry, on the ampersand on the p that we just got, and it will be okay. And the return value will be a valid shared reference, pin shared reference, because there's nothing to show for pin. So pin new now becomes easy. And second, the incorrectness, at least I'm ignoring correspondence size, but the incorrectness in the deref mute based thing is in whatever place calls pin new unchecked with a mutable reference.
Right, exactly.
Because, sorry, with a shared reference. Because the second clause of the invariant says if &t implements deref mute, then something must be shown. Whoever wrote that code says, oh, it doesn't, so I don't have to show anything. But they were wrong. And crucially, this is this kind of works because we are basically saying we call, like the invariant talks about this specific value of v, but the funny thing is it specifies the properties of the value of v, not in terms of the length has to be less than the capacity or something, but only in terms of when you call some functions on v, or actually on &v, because we're passing shared references. The only thing that the pin invariant says about the value is that you must be able to call certain functions on it, basically, which is kind of weird, but I think it works. And then we have to manually prove extra things about pin share and pin mute to justify to justify the specific operations for those pointer types, but that's easy because they're specific for a certain pointer type.
There are other.
Can I rephrase this to see if I understand it?
Yes,
I
please.
think what you're saying is, so pin share, I kind of wrote it there, but my understanding was this is sort of a fiction we're using in the proof, but essentially we've defined some invariant for ampersand t, and pin share is kind of a type that meets that invariant, that has that invariant, rather.
Well, so the invariant for an ampersand t is this is a pointer to some piece of memory that satisfies whatever the sharing invariant for t is, and the invariant for pin share of t is this is a pointer to some memory that satisfies whatever the pinned shared invariant for that t is. So every type has kind of these couple type states. It can be, and it can be mutable, it can be shared, it can be pinned, it can be unpinned, and this is basically that switching out the type state of the point t, which we don't have a good way to talk about in surface syntax, and I don't know how to explain it without a whiteboard and all of that, and some lectures, but I hope it makes some sense.
Yes, I think it did. And we're kind of, I think what you're saying is that we can sort of define the behavior of ampersand t, like what you were before saying had to be localized to the impl. We can kind of define it with this pin share, and then say when you call new unchecked, it has to be correct with respect to that behavior that we defined. But
well, we define it with pin share and pin mute for only 2 of the potentially infinitely many pinned pointer types.
right.
But the thing is, the only thing that you can ever do with any other pinned pointer type is deref them to get a mutable, to get one of these 2.
Yeah. And I
So
think
the only property that we care about for any other pinned pointer type is that you can call deref, mute, and clone. You don't need any. We basically only need these 3 Hort triples, so to speak. We only need these 3 statements that it's okay to call 3 certain functions on them, and then everything else gets reduced to the 2 kind of well-known pinned types.
I think that makes sense because that also covers, so like manually drop, for example, implements deref and deref mute, but can't be pinned because it is just like a new type. Because that then moving the manually drop moves the pin, and you don't need to express the invariant that's separately, because manually drops deref and deref mute just don't return a pin share and a pin mute, right? That's like they're not in the pointers they return are not in that type state.
Right. Yeah. So when I say
So
here return pin share or pin mute, that's a statement about the return value, right?
Right. And so that encompasses like all these other sort of vague invariants that we've been unable to like trying to express like all the different invariants that the different pointer types have to meet is just can be expressed through the fact that they do or do not return valid pin share and pin mute.
That is basically the idea, yes.
Yes.
So when you call new unchecked, you have to prove these conditions, right?
Yeah.
You have to basically at that point prove a Hort triple, or do program verification for the deref and deref mute with this when called on the specific pointer value that is passed to new unchecked.
Yes.
And you have a shortcut here if you can prove that a certain input doesn't exist. So this ties into being able to do negative reasoning, which is the entire story about fundamental and negative inputs. And I think it's more than that, because arg and RC are not fundamental, but we have to justify creating an RC and an arg, we have to prove that there can never be a deref mute for them.
Yeah.
And
that's why
they better don't be, but like I think we allow ourselves to relax the orphan rules in the future. So every such relaxation, we make those proofs potentially invalid.
Right. I feel pretty strongly that there should be some positive statement of the fact that there is.
Exactly. I think that this is a justification for this idea of these negative impulse where.
So basically, that will basically mean that you are only allowed to say that P doesn't impl deref mute if you have a positive witness of that. Only then are you allowed to not do that part of the.
In the long term, that sounds like ideal because then it's very simple to prove that it doesn't implement. Right.
Right. Plus, I think I was going to raise this point about orphan impulse and orphan rules. Like the orphan rules, first of all, the orphan rules are kind of weird. Like they're okay if you only have one type, you can kind of understand them, but
as soon as
more than one input type, it's really easy to get confused about what's allowed and what's not allowed. And it's not hard to imagine us trying to change them. And in fact, I think I tagged some people today on a proposal of centrals. Not that it's a good defined proposal, but it's exactly this, where the central is saying, well, for marker impls, for marker traits, which we haven't stabilized, there are no reason not to have overlap. So why not drop the orphan rules? And that makes a lot of sense in isolation, but it would be exactly the kind of.
I mean, there is pinning traits that rely on orphan rules being enforced for unpin.
What's that?
There are pinning traits for pin projections that rely on orphan rules being enforced for unpin.
Right.
It's opt-in for the specific traits, so you wouldn't opt in for those.
Yes. So unpin can't opt in unless we want to break these traits.
Yeah.
Yeah.
Right.
So having something explicitly negative, I mean, it also just is a good user feature, actually, because
it also makes a lot of sense in this entire chalk setup that you had with these modalities for like including all downstream traits and stuff like that.
Right.
So
right.
do you get to assume incoherence that the impl will never exist, or do you not get to assume?
That's the point of the negative statement, is then that is a statement that the impl will never exist.
But
breaking chains to remove that impl, just like breaking chains to remove any other impl.
Does the orphan check and coherence?
And coherence rely on that in the way that it currently doesn't.
Because Nico, I thought Nico had an idea that we wouldn't like it's the trade system would not allow it. You wouldn't get to assume.
No, well, I could see both, but I would think it would be useful. My usual example is I would like to be able to define that box is not copy and allow people to rely on that, which they currently can't, if I'm not mistaken. And it seems pretty safe to assume box will never be copy, but we can't state that in a way that the orphan rules can observe. And there's plenty of examples like this. So if you did, I think I may have forgotten about a complication, but I think if we were able to have negative impulse, we would conceivably be able to do such extensions like that, but I'd have to work it out a little bit.
But Central, I think what you might have been remembering is that it wouldn't be adding bounds. Like we would not support adding bounds that this type does not implement this trait.
I think but also I think in the thread I specifically said these don't all have to come together. We could add the ability to have a negative impulse as a temporary step, like to close this soundness hole without allowing other people to rely on that for the time being. Though I think it would be useful to allow them, but I would want to.
Right. We could ease in like step by step
And I mean, having negative bounds is a whole different kind of worse, right? At that point, you have negative information on the left of an implication that makes it even worse.
Well, yeah, that's why
we see how you would want to separate that, or maybe never do it.
I don't want you to be able to have negative. Yeah, I'm very.
I think we want monotonicity of our trait impulse. That everything else sounds.
Places we want to allow negative things, and not all for sure.
Like, I mean, the only thing that I think we can only allow that if it meant there is an explicit negative impulse for this type, which is.
All right. Well, specifically, we don't want to be able to say, "Oh, I see what you're saying." Yeah, but imagine. It's scary.
Okay. I guess it's still monotone in some sense, but yeah.
I
was even thinking, while thinking about back, for pin, what we might even want, like, though I don't think that we should add this in language, but what we kind of want is like a statement that this has a definitive resolution, right? Either you have negatively implemented dref mute, or you have implemented dref mute. Like
basically exclude the middle for this particular trait.
Exactly, yeah. But I think that is way too hard to explain to users to add to the actual language.
Maybe to ourselves as well.
But I mean, in the safety contract, this is explainable, right? The safety contract, you must either have an impl and then show something about the impl, or you must have a witness of a non-impl.
Yeah.
And by that contract, RC and ARC would also be wrong currently because they don't have a witness of a non-impl.
Right. So I think that this proposal would definitely, like, as part of resolving the soundness hole, we'd want to add the negative impulse for all of the types in the standard library.
What's also nice about this proposal is that we could formally prove things about it without modeling the entire trait system. because the plan that we have is basically to have one single file in our cork proof that summarizes the assumptions we are making about trait inputs that exist and don't exist. So we would somewhere say we assume that &t implements deref, and here's the code, and we assume that &t doesn't implement deref mute, and that these assumptions about the trait universe would be collected in one file, and then we could prove that under those assumptions, all of the pin contract stuff works out. But we wouldn't have to actually prove that the trait system correctly enforces these assumptions. That would be a separate proof. That's kind of nice because it means we can do something without modeling, well, chalk, basically.
So we should do that.
Yeah, we should do that, but that's a separate PhD thesis and it's not mine.
Yes.
I think this also, like, I was just saying, I just asserted that people will be depending on the orphan rules anyway, but it is like plausible to like tell people that, well, if you want to be really correct and resistant to any changes that we make in the future, you should also add this little line of code that makes it guaranteed that you'll never, like, if we have the ability to express these in the language, then
I think we would say that is the only way you should do it, and people may do whatever they will do, but
there's lots of things that we say that you should only do, but I think
for sure I can imagine they won't. But at least then, if someone can point out to them that it's wrong and have
exactly.
We can't prevent people from shooting themselves in the foot, but we can give them better tools.
Yeah.
There was a detail here that I don't think I was 100% clear on. We pointed out somewhere early on that fundamental traits were the cases that we were concerned of, things like box and ampersand. But then Ralph mentioned ARC and RC as being things that he was concerned about. And I'm still not clear on whether, it doesn't sound like there's actual known soundness holes there. Is that, so the thing I'm trying to jump to is this whole question of, oh, we need to like add negative impulse for everything standard library. Are we still need to add negative impulse just for the fundamental traits in standard library, or actually for everything in standard library?
Well, just for the deref, for the 3 traits for all of the pointer types, because so there's no way.
One sec, I'll be right back.
Yeah.
All the pointer. What can you define all the pointer types?
The 2 reference types, box, RC, and ARC. So all of them except for box and mutable reference need to have a negative impl of deref mute, and then mutable reference needs to have a negative impl of clone.
So the whole thing about fundamental was a red herring, because RC aren't fundamental, right?
But yeah, so fundamental is the only way you can actually have unsoundness that we know of, because fundamental actually allows you to implement deref mute for a shared reference. It does not allow you to implement deref mute for ARC because ARC isn't fundamental. Like, assuming the orphan rules are correct, there's no problem with ARC, but this allows us to not assume the orphan rules are correct. This allows us to just assert that ARC will never implement deref mute, even no matter what we do with the orphan rules.
I see, I get it, okay.
So why, I just have one quick question about RC and ARC. Where do we, apart from pin new, where do we see them in use? I didn't see how to make a pin RC. Maybe I just missed it.
They both have a constructor called pin, just like Box does, that creates a pinned RC.
Oh, okay. I was looking at the from impulse, but okay, they have a method on the.
Yeah, because they can't have a from, like, so Box also has from box to box, pin box, but you can't have that with RC and ARC because you could have another, it could have a positive.
Oh, got it. Okay. Yes. Of course, yes.
Yeah.
And so does this apply to like my special ARC in some third-party library?
Yeah, you would have to implement negatively implement deref mute to do that correctly. So I guess that if we're going to say
I'm back.
disable as negative impulse for this purpose, or we could, or today people would have it technically possibly unsound, but in reality, like fundamental isn't unstable, and we don't know any way other than fundamental to get around this. So for custom pointer types, like they would be like sort of in this state, but still a lot of stuff is in today where it's technically unsound, but there isn't really a solution. And in the long term, we have a solution. Like there's no exploit, an unstable solution, basically.
So in the very short term, we could implement those negative impulse just for the fundamental pointer types, and not RC and ARC, and deploy that, and then that would fix the soundness hole and have our long-term plan be to expand it, but we wouldn't have to stabilize negative impulse so quickly to soundness hole, the known soundness hole.
It could just be on our path toward.
But then we risk that if we ever improve, I would say, or orphan rules to allow more impulse.
Well, I think that we should add. I think because the standard library can depend on negative impulse immediately.
So the standard library can do whatever it wants, yes. But
So
if people use custom pointer types, or I mean, there's the owning ref thing already. Owning ref already seemingly does current-based reasoning because they were broken by the same exploit, or whatever is it the owning ref? One of the
or rental or whatever, one of those. Yeah.
All of those would be broken potentially if we ever improve coherence, which is kind of sad.
Right. So I think that we'd probably we would tie an improvement to coherence to making negative impulse stable. So like that would be
well, it would still break them, but then it would give them a way to fix it. Is that the point?
It doesn't feel great.
It's not great, but yeah.
That's the life.
I mean, the alternative is we can tell them don't do this, but
yeah.
I mean, that's just the story of unsafe code, right? Like,
yeah. Unsafe code is currently relying on things that maybe it can't rely on it.
There's no doubt unsafe code that relies on, it's supposed to be UB if you do X, but if we say, well, it was UB, now it's defined. This is compatible.
Yeah, I'm just thinking about the risks.
But this is different, Nico.
I don't feel this is. Why is this so different?
This is not relying on certain things being UB. This is relying on, like, I don't know, if filtrate stuff is, for me that feels very different, but maybe that's just because in my universe those are completely different things.
To me it doesn't. I mean, it feels conceptually to me like we've said certain things don't compile or can't occur, and people relying on that, I don't know, there's always this question of, does that mean now or does that mean in perpetuity? Like, is that a hard limit?
I personally feel relying on negative reasoning for things that are not enforced in the system itself for unsafe code is risky.
Right, I agree. Yes. Like, surely it would be wrong if you said, well, there's no clone impl for this pointer type. Unless there's some fundamental reason there can't be clone. You shouldn't lean on that.
Right, I mean, we've already told people that we can, like, you should not be relying on, like, standard library not implementing things for its types, because
unless you are the standard library, or perhaps it's like
so it's
the type in your crate.
Is owning ref wrong then for relying that ampersand doesn't implement deref mute because we can't rely on standard library not implementing certain things?
Well, that's the question.
Yeah,
I think votes, and I sort of inclined to agree, would say no, because we should be guaranteeing that. Unfortunately, we didn't. Because of the fundamental thing, we don't have a way.
So I think that.
And because we don't have negative, like, if we had the ability to say negative things, then we could say it, and then you can say you're relying on this explicit witness of negative reasoning, right? And that feels good.
At that point, you're relying on coherence. Well, you are, I guess, relying on coherence, but you're not relying on the orphan rules anymore, and that's important.
Yeah, that's what we want, I think.
I think that seems like clearly the long-term solution. That, like.
So we're at 1 hour.
Yeah.
Should we continue or should we not continue?
I would prefer if we wouldn't continue too much longer, because.
Yeah, I have to go soon. Really, I have to go very soon.
Yeah, I think we can stop now. We reached a point, but we have to figure out the next steps. That seems like that'll require.
Do you want more meetings?
I mean, the obvious thing is to write up a summary of this. But.
Yeah, and I think that action steps. I think we need to start exploring adding these explicit negative witnesses somehow. We never talked about coerce unsized, but I think that probably all kind of agree that we just make coerce unsized and safe and solve that problem. Or everyone.
So is there a good coerce unsized impl for pin that fixes this?
I mean, no. We coerce unsized is just another way to construct a pin of like a pin.
Right, but this relies on there is an impl coerce unsized for pin, right?
Yeah, and that impulse is fine, except
we'd have to remove that.
No, the impulse fine as long as it's just that a user could define their own coerce unsized for a pointer type that does not meet the pin requirements, in the same way that they can call. It's like a safe way to call new unchecked, basically, is what it is. Because you call pin new and then you use coerce unsized to get a pin of a.
Sounds like there's another fourth thing in this list of deref mute, and clone. Is it the case that we should also add and coerce unsized?
No, because coerce unsized is the way of creating a constructor. Because you do pin new, then you have a pin of a pointer, say to I32, then you can cast use coerce unsized to your pointer to dying display. That no longer necessarily implements unpin, you swap it out somehow with something else that implements display, but it's not actually on pin. So coarse and size is a constructor, just like new unchecked. And so we need to make it unsafe.
So you're saying every unsafe input coercer size is not just unsafe, every unsafe input coercer size needs to verify the pinning thing.
Yeah, or we add a marker trait for pin coarse and sized, but I don't know if there are people, like, I mean, see, it's unstable, so it's not that important. It's not urgent anyway, but like.
Well, but what is the fix currently? Like, okay, we make it unsafe, but then we still want ampersand I32 to coerce to ampersand dun display. So
well, it does, because just the trait is unsafe, so the impulse are all unsafe, because all of the types that implement coarse and sized on stable do meet the requirement, except for, you know, ampersand and ampersand mute, because they don't meet the requirement at all because of this problem. But
okay, I don't think I got that, but it's too late now.
We'll have to follow
today, I think.
table it, I think.
But I think the coarse and size is just a much smaller issue that either we add a marker trait or we make it unsafe, and we just decide whether.
But if we make it unsafe, I would like to have a good idea for what the thing is that whatever has to prove.
Yeah, I'm saying that it's the same as new unchecked, but we can talk more about that offline.
Okay.
Is there a third leg here?
No, that's.
These are
I think, no.
Complicated stuff.
I guess make it
like there's
the summaries.
I would say also write down the proof obligations for new unchecked. In some
I will write down. I will write a post in the pin unsoundness thread with the thing I wrote here.
It would be good to compare the relative complexity of the various how complicated it would be to prove different things, like with unsafe marker trait, etc.
Well, we won't do the proof multiple times, so.
It seems like we kind of consolidated on this approach with the negative reasoning. But what Central was saying is what I originally thought. Also, I would like to compare like an unsafe trait in DREF. If we had those two choices, that might be one way to choose between them.
But also the pin new, like you still have the negative reasoning aspect with pin new, even if you do use the marker traits.
Yeah.
Well, I mean, we would not if we also have pin new make
another marker trait.
Well, a marker trait, also a marker trait, also required. Basically, a DREF pin as a type bound to pin, and so also to pin new, and that would have an appropriate proof obligation. I think we had some idea there.
I think there's an issue with DREF mute there, though.
Okay.
Well, that has another. Well, there's multiple marker traits. Anyway,
I gotta admit, I'm confused again, because I thought that the whole point was we were not going to do the marker traits, and we're going to get impulse. We're going to fix that. But now the phrasing is, well, could add a marker trait for pin coarser size 2, which for 2 there implies people are adding others. Are we adding marker traits or not?
The coarse and size is quite different, actually, basically from the
like. So maybe the 2 is just questionable there. Okay.
2 is meant to be.
So it would be good to have like the full various different fixes, and then we can compare them, and like how complicated.
I would like to produce some sort of write-up of the whole thing. So maybe Boat and I can talk about it some more, and I can get some of these questions ruled out.
It's not the item for this team, but we are kind of. I mean, the intern that did the pin work has expressed interest in continuing some of that. So we do have the plan to actually formalize this second idea that I sketched, including the collecting the assumptions about the trade system somewhere to not have to formalize the trade system.
Cool. Okay.
So the goal is to make that a paper at some point. Yeah, we don't really have a timeline. So.
All right. Thanks, everybody.
Thank you all.
Yeah.
Bye.
Bye.
Bye.